Hello, everyone. Good evening. It's a pleasure having you in today's class. How you doing? How has your day been? Please confirm if you can hear me, if I'm audible. Am I audible? Okay, good evening, everyone. All right. How was your weekend? And how has your day been? All right, good to have you in class. We would wait for some other people to join. We are still very few. Okay. Good evening, everyone. I can see greetings from a lot of you. Good evening. So let's wait briefly for others to join. Is that okay? Nice. Yeah, good evening to everyone that has said good evening, Ma. Good evening, too. Okay, let's hold on for others to join the class. Okay, we're still very few. Hmm. Yeah, I'm here with you. Let's wait for some other people to join. We are still very few in class. So let's hold on. Yeah, I'm here. I'm here. I'm here. We are all good. So while we wait for others to join the class, can we do a quick recap of what we had last week? Can someone remind us of our last topic last week and what we actually did? It was still very few in class. I wouldn't want others to miss out. Yeah, Mr. Emmanuel is fine. He's very fine. He's doing well. He will come up very soon. Yeah, who asked about Mr. Emmanuel? Victoria. He's doing very well. He'll come up very soon. Thanks for asking about my colleague. Thank you so much. Okay, so what was the last thing we did last week? What we did last week? Can someone remind us? IT concept, right? IP, basic IT concept, key components, basic IT concept. Good evening, everyone. Okay, so what are the basic IT concepts we talked about? Yeah, what are the basic IT concepts we discussed last week? Yeah, I'm waiting for the basic IT concepts. Please, can we just do a quick recap? Virtualization, operating system. Okay. So when you answer, you're going to tell us briefly what you understood by those concepts. Is that okay? Okay, so IP address, static and dynamic IP, command line, operating system files, IP address, port, command line, and virtualization. Okay, we're still very few in class today. What's happening? All right, so I said we were going to do a quick one before we get into what we have for today. I talked about static and dynamic IP, right? So I asked us to check or look out for our individual IP address on our devices, right? So I want to know if those that were not able to come up with their IP address, if they were able to do that during the weekend. If not, what was the challenge? And for those that did, I said we're going to check again and we'll know if yours is static or dynamic. Can we still remember? No, classes are Upabio, classes are Tuesdays, Thursdays, and Fridays. Okay, so can you hear me? Okay. All right. So I said we were going to do something quickly, right? Um, we had checked our IP address last week before we ended our class. So, and I said we were going to do another check today to find out if yours is static or dynamic. So I want you to do that quickly. I asked you to write down the IP address you got last week to keep it safe, and then we're going to get to try again and see if it's the same IP address. All right, so can we do that quickly? We'll just take like 3 minutes of our time to confirm if, oh, nice. Bamidele said, my IP address is static. We ended with, who's that? Michael said we ended with components and benefits of virtualization. Friday class changed to Saturday. No. We learned about basic IT. So yeah, I know we learned about, okay, mine is static, mine is dynamic. Nyabi said mine is dynamic, mine is static, mine is dynamic, mine is static, right? So have you seen that some are dynamic, some have dynamic IP address, while some IP address remains static? Okay, so I want you to go back to, I don't know if the materials are available. If they're available, you would know why yours is static and why some other person's is dynamic. Okay. All right. For today, we're going to. Oh, okay. Mine is static. How do we check it? Clement, I said just go to your command prompt and click ipconfig. Press enter after typing that, and then you're good to go. Okay. Right. Who still has issues? Yeah, who still has issues with IP address? Mine is static, all right. And you'll know if it's static, Emmanuel Anthony, you'll know if it's static if the same IP address you got last time you checked is still the same IP address you're getting now after you have checked. So we are still very few in class. I don't know what happened. Okay, I said you would know if it's either static or dynamic if there is a variance in the IP address. If there's a difference between the one you checked last time and the one you just checked now. So if they are different, it's dynamic. If they are static, is it means it's static, because we talked about static and dynamic kind of IP address, right? So you could just refresh and then know the difference between static kind of IP address and then the dynamic type of IP address. All right. Oh, I'm sorry. Who said you're confused? Salisu Usman. Why are you confused? Yeah, Salisu Usman Bilkisu. Why are you confused? Is there a problem? Yeah, Moses, it doesn't matter the network you're connected to. Bamidele, why IP address different? And we talked about that the previous class when we discussed. Yeah, good evening, King David. Oh, oh, Basi said maybe some people are not aware of the class. How? Okay, is there a problem? Is there a mix up somewhere? Our classes are Tuesdays, Thursdays, and Fridays. Please, people shouldn't miss classes. It's very important. Godwin, as the what is it that you didn't get? All right, so how do we check the IP address now? Okay, go to command prompt, click on your command prompt on that black interface, all right? We did that last week, and then you'll see the interface. Just type ipconfig, right? Okay. Murphy Blessing, good evening. Mine is static. All right, nice. So now you will need to go back to check why yours is static. And for those that theirs is dynamic, you need to go and read up to know why yours is dynamic as well. Okay, back to the business of today. We're going to be talking about network, right? In cybersecurity, you're trying to secure your space. You're trying to secure your cyberspace, and it has to do with a whole lot of things. Okay, so we're trying to try as much as we can to put all of these basics in place before you'll be doing a handful of hands on this week, right? So we'll be checking. So you need to know what network is, what it entails, what network does, and the whole activities that happen behind or within a network. All right. So today we're going to be looking at what network is, the OSI, the TCP models. All right. So now what is a network? What is a network? Please pay attention, right? Network is different from what you think is actually what you actually think it is. Okay, so a network is a collection of devices that are connected to each other to share resources such as data and hardware. Okay, so in today's world, networks are essential for various activities, including accessing the internet, sharing files and documents, communicating via emails and messaging, streaming media, online gaming, and social networking. So, in today's world, when we talk about network, we are talking about a whole lot of activities that happen. One, not just accessing the internet, all right? So, accessing the internet is one of the activities that happen in a network. I want to put that very, very straight to us. So when you hear about network, I know most times you just feel, okay, it has to be all the time it has to be with the internet, right? So, but accessing the internet is just one of the activities that take place in a network. So if you asked what a network is, it is a collection of devices, right, that are connected to each other to share resources. For instance, if you're not streaming live, maybe YouTube live or a YouTube music or all of this, you have your let's say your music box, all right, like your MP3 player and all of that, and then you're not on the internet. There is a connection between your probably your phone or your device, right, where your music are stored, and then your music box. And then when there is this connection, it's a network. You're not using the internet to do that, right? You're not using any internet, any form of internet to connect to your Bluetooth, isn't it? So it is a kind of sharing files, sharing streaming media and all of that. Okay, so once we talk about network, it shouldn't just be the internet that comes into your mind, because I know that most of us, once you hear network, what just comes into your mind is the internet. Am I right? Am I right on this? Please, we're done past checking of IP address. We are already in for today's class. All right. So if you look at all of these that I just stated here, accessing the internet is just one of these activities that go on in a network. Sharing files and documents, communicating via emails and messaging, streaming media, online gaming, and social network. Next slide. Next slide, please. Okay. Now, what are the key points about networks? One, interconnected devices. Networks connect various devices such as nodes, enabling them to interact. The typical example I gave, right? I gave it in the points of you understanding that network doesn't really have to do with internet all of the time, all right? Maybe a service provider providing you internet before devices can be connected, all right? So the key points about networks: one, interconnected devices. Networks connect various devices known as nodes, enabling them to interact. Communication. Networks allow devices to exchange data, messages, and information. Resource sharing. Networks facilitate the sharing of hardware like printers and software like applications and data. You also agree with me on that. Why I am not particularly interested in the internet aspect of network is that most of us know that, yes, you want to get something from the internet space, there must be like an internet service provider that needs to avail that connection between your device and then the server, right? That's aside. But for resource sharing, which is also part of resource sharing, mind you, it is also part of resource sharing, getting resources from the internet to your devices. All of these are part of resource sharing. But in a scenario whereby we are not talking about the internet, you should also think of network in that line. All right. So resource sharing also could be your printers, your devices connecting to your printers. You don't need the internet for that, isn't it? You want to print out something from your system to your from your system, you want to print out something, there must be a connection between your device and your printer. It's network. It's networking, right? So you don't need the internet for you to be able to print out your documents from your device via your printer. So all of these are also part of resource sharing, apart from getting those resources from the internet or from the server. All right. So now the fourth here is connectivity. Networks can span small areas like a home or office or vast geographical distances connecting cities, countries, or even the globe. All right, so these are key points about networks. One, interconnected devices, they interconnect devices, whether online or offline, right? Communication, network allow devices to exchange data, message, and information online, offline, right? Resource sharing, both online and offline, okay? Connectivity, same here, right? So all of these are key points about network. All right. So we're going to look at types of network. Types of network. Now, before we go to types of network, we are still very few in class. What's happening? Okay, we're still very, very few in class, but it's fine. I pray it won't affect them in any way, but let's go ahead. So before I continue, from what I just explained, can someone tell me, apart from you getting information from the server, that is from the internet and all of that, and maybe connecting to your devices, are there other means of connecting devices you can share? Some other means of connecting devices. Yes, I'm waiting. Some other means of connecting devices that we can talk about. Yeah, I'm waiting, please. Some other means of connecting devices. Wi-Fi, HDMI, through LAN, USB or flash drives, Bluetooth, yeah, Xender, using of LAN cables, connecting through USB, Bluetooth. Okay, nice. Scanner through RJ35, LAN, VGA, HDMI, text messages, normal, all work with network. Ah, who said all work? Okay. Hope you're not saying all work with the internet. Through cloud, Xender, through Bluetooth, Xender fiber, Wi-Fi LAN, through Xender, yeah, Bluetooth, okay. Through airdrop, special nets, wire. Oh, nice. Thank you very much. So it means we are infrared, HDMI, hard drive, HDMI. Nice. Okay, so beautiful. Now we are together. Now let's look at types of networks. Okay, networks can be categorized based on size, geographical span, and purpose. One, we have personal area network. This has to do with just a small network within an individual space. So who can give me an example of that? Of course, I've even written it here. So for the personal area network, if it is a network within an individual's workspace or an individual space, what could be a perfect example for that? Bluetooth connection. Nice. This connects devices like your smartphones, your laptops, um, and peripherals, printers, headphones within a short range, right? Wi-Fi router, exactly. Projector, Wi-Fi, computer, and a printer. X share, flash, quick share, all of these are personal area networks. Okay, good. Wi-Fi is a perfect. Nice. Wi-Fi routers and that. Nice. Okay. So let's look at the next one, the next type of network. Now we have also the local area network. This kind of network connects devices within a limited geographical area, such as a home, office, or building, used for sharing resources like files, printers, and internet. Examples are Ethernet network in an office, Wi-Fi network in a home. So now, when you'll be doing your first hands-on on your network on packet analysis, network packet analysis, you will see options for you to either check for Ethernet network or for Wi-Fi. So when you get there, you now know the difference between those two networks, right? Okay, now then we have the metropolitan area network. This is larger than the local area network, and it covers city or metropolitan area, connects multiple lands together, and these are used by service providers, e.g., cable companies, to provide internet access. All right, so most times you see a lot of fiber optic wire being buried, right? Cable, sorry, being buried on the ground. These are channels where networks are being, you know, resources are being shared, right? So if I have a MiFi, for instance, that's for my personal area network. I just use it for myself personally. And then I go to a city where there is no metropolitan area network. It's possible I won't be able to access, I won't be able to use that my PAN, my personal area network, like my MiFi or my Wi-Fi. Alright. So the metropolitan area network is a larger kind of that covers both the land and the man. So without that, most times if you want to gain access to the internet, you won't be able to do that. All right. Oh, nice. Tunde said he is a fiber optics engineer. So do you want to tell us more about fiber optics? All right. Next, please. Okay. So now we have also the wide area network. Sorry about that. We have the wide area network, which spans large geographical distances, connecting networks across countries or continents. And it's used to connect lands, mans over long distances. All right. The internet is the largest wide area network. See, this is where the internet falls now. So you cannot say the internet is is a personal area network. No, it falls in this type of network, the wide area network, because there are a lot of things that you get outside your continent as a result of gaining access to the internet. Okay, there are things you get outside your continent, outside your country, outside your states, outside your province, as a result of you gaining access to the internet. So it's a wide area network. It's not limited to your your geographical area. It's not limited to your office. It's not limited to your home, right? It's limited. It has no limit. It's just wide. It goes right wide, and that is why when you want to search, most times you have www, right? Which is, what tell me the meaning of www? What's the meaning of www? Can we drop it on the chat? All right. So now the next is the virtual private network, VPN. Virtual private network. If you have used a VPN before now, or yeah, can you just send a thumbs up? If you had used VPN before now, send a thumbs up. Yeah, I'm waiting. This VPN we're about to talk about, have you used it before? How many have used VPN before? There was a time in my country when a particular social media handle was banned, right? And I'm very sure some people were still gaining access to that particular social media handle. Am I correct on that? I can't see your comments. Please, am I audible? Am I still with you? Am I audible? Okay. So, before I talk about VPN, which is the virtual private network, I would want us to, yeah, I said in my country where I reside currently, there was a time that a particular social media um, platform was banned. And I said, I am sure some of you still gained access. So I want to be sure I'm correct on what I said. Okay, I can't see your comments any longer. They're not coming up. All right. So a lot of people gained access to that social media platform that was banned. I'm talking of what happened in my own country, right? So, and a lot of people were using the virtual private network. Let's see what it actually does and how people were able to use the VPN even when a particular social media platform was banned, right? So, a VPN is a technology that creates a secure encrypted connection over a public network like the internet. All right. And what it actually does is it allows users to access a private network remotely as if they were directly connected to it. This is one, right? Then it's used for secure remote access, which is two. It's used for privacy, which is three, and bypassing geographical restriction, which is four. So why you were able to connect to that, or why you were able to use that particular social media platform, was because you were able to bypass geographical restriction because we're using the VPN actually. So the VPN, in other words, somehow encrypts or keeps your connection secret. Okay, so that is what it does. Ah, that is what it does. All right. So if you're able to do that, I want to see your thumbs up. Yeah, if you're able to gain access to what I talked about, can I see your thumbs up? Let me see the guys that used VPN. Yeah, Patience said she uses VPN while working from home. Yeah. Nice. Game over. We cut you right. Okay. Exactly. Yeah. Love it, God's gifts. Exactly. Noted. Okay, nice. Mm. So a lot of us, most organizations actually use VPN for work. Okay. Yeah, most organizations also use VPN for work. They want to protect, or they want to secure their their network. They use VPN. Oh, I'm sorry, your screen is blurry. Are you sure it's not your network? Oh, someone said I used VPN back for free internet data. Nice. Someone said, is my screen actually blurred? Queen said she has never used VPN. Okay, hopefully before the end of this um, project, right, you'll be able to know how to set up a VPN, right? Okay, it's fine. Okay, so if you have not used a VPN before, it's not a problem. Okay, okay. Someone said it's not blur. All right, nice. So that's what the VPN actually does, right? It's a technology on its own. So you can be here in Nigeria or in wherever location you are, and you'll be able to access the internet, and no one really knows where you're gaining you're accessing it from. Okay, no one can really trace. And also, it is one of the tools that hackers use in getting access to people's um, network. All right, so let's go to the next. Don't worry, King David. Before the end of this project, right? For those that have not used VPN, you would use VPN. You'll be able to set up your VPN. Yes, VPN can be used legally. Can be used legally. Is VPN 100% secure? As I said in our first session, there is no network that is 100% secure. So just have that at the back of your mind. Yeah, that much, Dre. How can we set up VPN, ma? We'll do that before the end of your project, right? Hopefully, we'll have time to do all of this setup. Okay, Annie Joel said that's true. At some point, I was using VPN for Twitter when it was banned. Oh, nice. So someone has really confirmed what I was saying. Hmm? So next time when they ban any other thing, you just try to look for. I'm not teaching you something bad, but well, let's go ahead. Devices in a network can include computers, which computers are the end devices that users interact with to access network resources. Okay, let me answer Esther. She says, what's the difference between a personal area network and a local area network? Personal area network just has to do with your personal space, your workspace. Someone probably downstairs or somewhere else very close, you might not be able to gain access to that kind of network. But for LAN, it can span through your offices and all of that. Okay, so a larger part of the personal area network, it covers a larger space. Okay, I said VPN, no network is 100% safe. So when you're looking for 100% safe network, it means, well, I can't say, but no network is 100% safe. Okay, so nice. Devices in a network can include computers. No, I'm sorry, King David, it's not allowed here. Can we have your, no, 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 no. Okay, so devices in the network can include computers. They are end devices that users interact with to access network resources. True? Yeah, true. Servers. It's a powerful computers that provide resources and services to other devices on the network. Talking about servers, you know what servers are, right? That you're able to browse the internet, and then you send a query to a server through your browser. Okay, you send a query. When I talk about query, I mean that thing you type. For instance, what is cybersecurity? Right, you use Google, right? Or yeah, Google Chrome to type what is cybersecurity. Google Chrome is a browser, and then it now sends that query to a server, right? So that is why you have a lot of definition from your browser, right? So it goes and gets different definition of what cybersecurity is from different servers, right? So a server or servers are powerful computers that provide resources and services to other devices on the network. Okay. Then routers are devices that determine the best path for data to travel. We're just scratching the surface. So don't get confused. I'm trying to be very, very, I don't know, for you to understand so you don't get confused. Okay. So now we have switches, forward data packets. I said we'll be doing packet analysis. Don't worry, packet analysis is our hands-on for this particular week, right? So when you hear packets, don't worry, you will see them when it's time to do your hands-on, hopefully on Friday, okay? So don't worry about all of these, our talk. You see them when we're doing our packet analysis using Wireshark and all of that. So forward data packets only to the intended recipients and thereby improving network efficiency. So if you don't want to miss out, right? If you don't want to miss out on all of this, then you should be in class from today. We still have another session on Thursday and on Friday when we'll be doing our packet analysis and Wireshark demo. Then we'll have a live traffic capture. You'll be able to capture networks, okay? So if you don't want to miss out, don't miss the class. Is that okay? Someone said, let's get started. You can't wait, isn't it? Who said there's no class on Friday? Oh, Thursdays and Saturdays. Oh, I'm yet to get that information. All right, let's not talk about our future class. Let's continue. Then switches. Switches forward data packets only to the intended recipients, thereby improving network efficiency. Then firewalls, security devices that protect networks from unauthorized access. I think I talked about firewall um last week, right? That every net and every device comes with a firewall, an inbuilt firewall that protects the networks from unauthorized access. So preventing flow of networks into your devices, right, without it being checked. Then it also control incoming and outgoing network traffic based on predefined rules. And that is why most times, if you're using an office laptop, for those that are using office devices, right, there are some websites or there are some yes, there are some servers or there are some servers that you cannot, no matter what you do, you will not get access to information from those servers, right? Am I right on that? If you're using your office device based on the predefined rules for that particular system, there are some information that you cannot, there are some websites that you won't be able to, right? There are some websites that you won't be able to get any resource from because it has already been predefined that from this IP address to so IP address, there is a block, like it is being blocked from gaining access to that device. All right. So once you're not able to gain access to some websites, probably your admin, your IT admin has configured it in such manner. Yeah. So for those that are using office devices, am I right on that? Yeah, you're taking attendance. Sure, it's not time for attendance. So okay, next please. Yeah, you see, okay. Patience said, in my office, we don't have access to YouTube. Nice. So it's been blocked. No matter what you do, YouTube cannot break the firewall that has been put in place. All right. So it's very possible. Some you don't gain access even to your private email. It's very possible. Who is that? Philip. But if I change my IP address, can I still access? I don't understand your question. Yeah, not in all case, ma. Abayomi, well, it's relative. I said in some organizations, okay? Depending on whatever your IT wants. Have an IT department, they usually configure systems based on roles, right? And then they put firewalls in place for some particular IPs not to get across your devices. I'm very sure of what I'm saying. I'll say denial of access. Very correct. You will still need an admin password to use VPN. Yes, you're right. Restriction, right? Yeah. Okay, so now let's look at the OSI model. Oh, I'm just saying this notice for Thursday class. Thursday class has changed from 7 p.m. Okay, well, it's fine. Yeah, Shinelu, firewall is like a boundary. It's like a fence. Yeah. Hmm. Can the firewall be bypassed? Yeah, if you're using the VPN, yes. No, VPN not work for those predefined sites. Yeah, it doesn't. Okay, it's fine. I'll check that out. Okay, so now let's go ahead. Let's go ahead. Yeah, the firewall can be bypassed. If you're using a VPN, you can bypass the firewall. All right, so now the OSI model. Okay, we're going to look at the OSI model. The OSI stands for Open System Interconnection Reference Model, and it is a way to describe how different parts of a network communicate with each other. And this breaks down the network into 7 layers. So for networks, we have the 7 OSI model for each network, right? So let's look at layer 1. Layer 1 is called the physical layer. Layer 1 is called the physical layer. And the physical layer sets the rules for the electrical and physical connection of devices. That's the layer 1. The physical layer does the following one. It starts and ends connections to the network. So if you're using an electrical kind of either electrical or wireless or physical connection of devices, it is at this point that the connection is being initialized. Okay, so when you're doing a physical, when you're at the physical layer, it means that it sets the rules for every connection, right? Secondly, it helps multiple users share the network smoothly, like managing data flow. So this is what layer 1 of the OSI model, what it does. Next slide, please. Layer 2, we have the data link. The data link here provides reliable data transfer between two directly connected nodes, and it handles framing, addressing, which is MAC, and error detection. Okay, so at this point, there is also a connection between the two devices, a reliable data transfer. When they are connected at the layer 1, then the second thing that happens is for the transfer to be possible. And this is what the layer 2 does. All right. Once the layer 1 is done with connecting the devices that are in question to be connected, right, then there is now the availability for those data, or the transfer of data between, the direct transfer of data between um, the devices. Okay, let me give you a live scenario of what I'm trying to explain here. For instance, if you want to, I don't know if you had witnessed something like searching using a particular what's it called, a particular browser to search for whatever resource you want on the internet, and you were not able to get a response, or there was no feedback. All right, and then probably you used Chrome for that, and then you were not able to gain access to whatever resources you were looking at for. It means that there was no, um, at the layer 1 level, there was no connection. It wasn't connected. There was no connection between the server and your browser. So at that point, you were not able to gain access to any resource. All right. But eventually you have another browser, probably maybe the Edge, right? And then you still type in that same query, right? Using Edge. And then you get your response. It means at that point, the browser and your server, which the browser here now is the Edge, and the server had connection and then there was data transfer. So because there was no connection in the first place, when you used probably Google to search for something, you were not able to get a response, right? And then you used another browser to search for the same thing, and then you got a response. So have we seen that at a point there was no connection, there was no from the first layer there was no connection, so there wasn't able to give out there was no reliable means of transferring the data to you. So if your layer one is not in place, that is, if there's no connection in layer one, it means you won't be able to gain access. There won't be a data being transferred to you, or there won't be data transferred to you. So this is just a live scenario of how layer one and layer two works. If there is a connection, if there is a start up connection from your browser to the server, then layer two will now be able to transfer that data or that resource you're looking for. All right, am I understood on this? Am I understood on this? Okay, next, please. Next, please. Okay, layer three. Layer three of the OSI model. We are talking of layer one. We are talking of layer two. Layer one is called, who can remind us of what layer one is called? Layer one, what is it called? My people, will talk to me. Our first layer, what is it called? Layer one, what is it called? What's the name? Okay, the physical layer. Then layer two. Hope my explanation was understood. Okay, she said not so well. Okay, the physical layer here, I said, please, can you hear me? Okay. Okay, so let me we need to hurry up. Okay, someone said I should explain again. Okay, so let me do the explanation, please, for layer one and layer two. Okay. Okay, so I said layer one, which is the physical layer. There has to be it starts up the connection between devices that need to either transfer and receive data. So at that layer one, there must be a connection, okay? And I tried using our browser and the server to illustrate that layer, all right? So layer one actually does a physical connection between devices that need to share resources. Okay, so there must be a connection at that physical layer, at the layer one. There must be a physical connection. And I said, for instance, you want to get a resource from a server or the internet. Let me use the internet now so you would understand clearly. Okay, so the first thing you do is you go to Chrome, your Google Chrome, okay, and then you type what is OSI model. All right, you're using Chrome at this point. All right, so once you type what is OSI model, you send it as you sent the query through your browser, which is the Google Chrome, to the server. Okay. And I said most times, or sometimes, not sometimes, right? Depending on your network, depending on the connection that happened, most times it might come up and say the network or the page is not available, or temporary, you can't reach this, something like that. Just an error message comes up, okay, because there was no proper connection between your device, which is your system at this point, your browser included, and then the server. Then you said, okay, I have Edge. Let me use Edge, another browser, right, to try and get this information. And then you leave Chrome, you open your Edge, and then you type the same, what is OSI model? And then immediately it comes up. While when you used Chrome, you were not able to gain access because there was no connection. There was no connection. There was no startup connection between your device and the server. So that is what the physical layer does. There must be a connection for the layer 2, which is the data layer, to be able to exchange those resources to you. So when you don't have the physical connection, it means you can gain access to whatever. There won't be a transfer of the information you're looking out for. Okay? All right. So now we'll go on a short break, and then when we come back, we'll continue. Okay, so welcome back. We were actually talking about the OSI models and their various levels. So we have talked about the level one, sorry, the layer one, which is the physical layer, and the layer two, which is the data link layer. And someone was asking if I read some comments that is 404 page not found part of the whole thing? Yeah, 404 page not found is part of a script written back end that either signifies that that particular that particular page cannot be found on the database, all right, or your network is bad. Either of this, it's not necessarily that the network is not connecting or something, but probably that page is not part of whatever is stored in the database, all right. So let me explain again the first one, which is the layer one, that is the physical layer, the layer two. I think I've explained that enough. Then now layer three, we have the network layer. The network layer handles directing data on the network, that is routing. Then breaking down and putting together data packets, and then reporting delivery errors, right? So all of these are what happens in or at the network layer. Okay, let me explain this further. Directing, it's just like, it's like, since we know that these data are moved in packets, they are called data packets. What network layer does is it looks for the fastest route for that data to be delivered. And if you agree with me, most times there are internet service providers that you might be using and they deliver faster than the others, right? Because at this point, the network layer looks for a faster route to get your response to you. Okay, for instance, if you're browsing, just let's use the browsers, and then you find out that um, let's say Google is faster than Edge in some cases, you're having, or Firefox, all of this. You just have, these are looking for routes that are faster, that transmit these data packets within a jiffy. Okay, so that is what happens here. It directs the data on the network, looking for a faster route by routing, and looking for how best these data packets can get to their destination, and then comes back again, gathers the data packets, and then send. Don't worry, on the last day of for our class for the week, you will be doing packet analysis. So there will be a memo, there will be a demonstration of how this data will analyze packets, which are data packets and all of that. So please, you might understand it better, but know that at the network level, which is the layer three level, then you had your connection. The connection has been made at the physical layer, and then your data, it has a reliable means of it's being transferred. And now, how do we get this layer and this data transferred? It has to go through the network layer, directing data on the network, so that you don't get we don't get mixed up, right? You don't get data mixed up and all of that. So next, please. The next one is, next, please. Okay, the next is the transport layer. The transport layer provides transparent transfer of data between end user, providing reliable data transfer service to the upper layers. And yet the transport layer controls the reliability of a given link I want us to listen. The reliability of a given link through flow control, segmentation, desegmentation, and error control. How many of us have witnessed this when you click on a particular link, right? And then it keeps bumping, bumping, and then you are now redirected. Have you ever been redirected to another link? Yes or no? Yeah, class. Have you been redirected to another link? Okay, several times. So all of this happens here. All of this, the redirection of links, segmentation, desegmentation, yeah, many times. Especially, I'll call one. I'm not too sure, but there's one that starts with one. Most times you are being redirected to that particular website. I don't know what they're actually looking for. There's one particular website in my own part of the world that usually somebody has dropped it. Exactly, backlinks. Always, people are always being redirected to backlinks. They're always being redirected. So it is at this point that you're okay. These links are not reliable. There's a segmentation at this point. There's a flow, there's let's say the flow of whatever you're looking for has been drifted, or it's been drifted away. So you are being, the link is, so most times you're not, once it gets to this point that this is what happens, there are a lot of redirections and all of that, error controls. It is at this layer that it happens. Okay, so all of this are what happens to us real time. Then the next one is the session layer. Someone wrote the company. Yeah. The fifth layer is the session layer. The session layer manages the conversation, which is the connections between computers. It setups, maintains, and ends the connection between local and remote application. All right. It supports different types of communication: full duplex, half duplex, and simplex. These are forms of communication. All right. So at this session, it manages conversation. For instance, a lot of us here, most times you say, I can't hear you. Your system is blurred, while others can hear me clearly and they don't have issues with the visuals, right? It is at this point that maybe you're having a disconnect. Okay, so at this session layer, your connection might not be steady, and that's why you keep having, most times you can hear me, I can't hear you, right? Most times I can hear you, I can just read you, and people say, I can't hear you, I can't hear you. At this point, there's a disconnect between the devices, between my own device and your device, right? So it is at this session that all of this happens. When you have a smooth conversation, you have a smooth communication, it all happens at this layer, all right? This layer manages conversation between computers, all of its setups, it maintains the conversation flow, and also even end connections. Most times you are being thrown out of the network because your session layer isn't strong enough to retain the conversation or retain the connection. Am I understood? What is simplest? Please, you can just read up, browse. With these communication types are full duplex, half duplex, and simplex. These are forms of communication. So you can just read, you can read up. It's not something you can't understand. All right. So now, even if you're using, during maybe your meetings, you're on a conference call, you're having your meetings online, this happens, all right? Connections are being altered and all of that. So now the sixth layer is called the presentation layer. The presentation layer presents data in a format that is understandable by applications. It handles data formatting, encryption, and compression. Now, the seventh layer. No, fine, move, move. So someone said here, who should we blame for this redirection to backlinks, the government or individuals? Well, you know, and most of these links that just pops up and then redirects people, they go to networks that generates a lot of traffic. Okay, and also you should also note that most times hackers use this link also to redirect people. Do you understand? So they use this link to also redirect people. Maybe you want to make payments, and then all of a sudden you're being redirected. At that point, don't continue. All right, don't continue. Most times they go to networks that generate a lot of traffic. What I mean by a lot of traffic is they know that a lot of people go into that website to do a lot of things. So they just come in, gain access, and then they do their things, right? And most times also it's used for advertisement and all of that. Mind you, not all adverts are legit. Not all adverts are legit. All right. So someone is already marketing purposes. I want to read up SSL's shrine. Must we have Linux OS? Very annoying. Hardware. True. Can't we be using Google or Zoom? You mean for this meeting? Okay, this YouTube network is bad. Probably it's from your end. All right, very well. Okay, I said you should read up on the full duplex, the half duplex, and simplex. These are just forms of communication over a network. Right now, the last layer we're going to look at here is the application layer, which is the seventh layer. This application layer is the layer closest to the end user. It is closest to you and I. Means that both the OSI application layer and the user interact directly with the software application. That you're able to hear me, that you're able to see my screen, that I'm able to see your chats is as a result of the application layer. All right. At this point, it identifies communication partners, right? It also determines resource availability. Okay, so you can see whatever I'm doing. You can hear me clearly. I'm not there with you, but all of these are the functionality of the application layer. That is what it does. It is closest to the end user, which is you and I, all right? So you're able to hear me, you're able to see my screen, you're able to, we're able to like communicate, isn't it? It is as a result of our application layer being put in place. In fact, synchronizing communication, which is what we are doing, right? Right. Okay. Now, any question on this? Samuel Estienne, you asked me to come again on what? Please make yourself more clear. All right, so now if there are no questions, I'm going to do a recap of this OSI model we talked about. Someone was asking the meaning of OSI. OSI stands for Open System Interconnection Reference Model. open system interconnection reference model. And I said it's a way of describing how different parts of a network communicate with each other. Remember, we had talked about network when we started the class, right? So how do this connection, what happens at each level when you're starting up a connection? What happens? What really happens at this level? So this is what the OSI model talks about, all right? And then we're able to talk about the first layer, which is the physical layer. I said the physical layer, there has to be a connection, all right? It sets the rules. It sets the rules for physical or even wireless or wired connection. It sets the rules, all right? So there has to be a startup, and also it helps multiple users to gain access to networks, okay? Then we talked about the layer 2, which is the data link layer, that there must be a connection that happens at the layer 1 before data can be transferred effectively, all right? So there must be a handshake, a sort of, before data can be transferred. And then the network layer that directs data, which is routing, looking for the fastest and easiest way for data to get to its destination, and then reassembles data packets back to its original state when it gets to the user or to the endpoint. Then we now have the transport layer. Here, the transport layer provides transparent transfer of data between end users, and then provide reliable data transfer service to the upper layers, okay? Then we have the fifth layer, which is the session layer. It maintains conversation. As I said, at this point, you are connected, okay? There is a connection between devices, and then what maintains this connectivity, it is the session layer. Here you can see what I'm doing, you can hear there is a sustainability of the connection that had been created at the physical layer. So this is what happens here at the session layer, then presentation layer, and then finally we have our last layer that we just talked about, which is the application layer, that helps us identify your partners and determine resource availability. Okay. Oh yes, Philip, I've seen that you suggest we include diagrams in the presentation. It's okay. The most important thing in cybersecurity is getting your hands dirty, right? So by the time you get busy, you forget about all of the diagram. The main diagram will be in your head by the time you start your hands on, okay? So don't be too bothered about the diagrams, all right? So now we're going to talk about TCP/IP. Next slide, please, for them to see. Okay, love it. You'll be sent the link, right? The technical assistants will do that. They'll do that as soon as they get to read those particular charts, all right? Okay, now we're going to look at the TCP. The TCP stands for Transmission Control Protocol, while IP stands for Internet Protocol, right? So what do they really do? The Internet Protocol suites, the both of them are called the Internet Protocol suites, right? And they are set of communication protocols used for the Internet and other similar networks. This one, you cannot do anything if TCP and IP is not in place. You can't do anything on the internet. Okay, so while the OSI model can be used for networking, whether physical wired or wireless, right? For TCP IP model, they are solely used for the internet, communication protocols used for the internet. All right. So if this communication protocol is not in place, you cannot get anything from the internet. All right. So it is named from two of the most important protocols, the transmission control protocol, which is the TCP, and the internet protocol, which is IP. Okay, next slide. Next slide, please. For the TCP IP model, we have 7 layers for the OSI model. Why for this particular model, we have 4 layers. We have 4 layers: the application layer, the transport layer, the internet layer, and then we have the network access layer. All right, these are the 4 layers we have on our TCP IP model. Next slide, please. Okay, don't worry. If you don't worry about the layer, I will do a diagram and send across. Maybe I'll add it up, so I'll do a diagram. Okay, if that will make you feel better. Practical, 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 practical. Don't worry, practical is coming. Make sure when it comes, you don't run away and you don't complain. Okay. Right. So now for application layer here, application layer provides interfaces for applications to access network services, combines the function of the OSI model, which is the presentation and the session layers, right? Examples of this is the HTTP, the FTP, the SMTP, and the DNS. Next class, I'll ask what this is all about, right? Then we have the transport layer. Okay, then we have the transport layer here. The transport layer provides reliable, ordered delivery of data between applications. They handle segmentation, flow control, and error control, just like the transport layer in our OSI model, right? And they correspond to the OSI transport layer, as I said. And the examples for this, remember we're talking about the internet, is the TCP and then the UDP. I think I should be getting questions. What is TCP? What is UDP? All right, next. Next, please. Next slide. Okay, then we have the internet. We now have the internet layer. What does it do? Routes data packets across network, handles logical addressing, that is the IP and routing, then corresponds to the OSI network layer, right? Remember what the network layer does? The OSI network layer, it looks for the fastest route to deliver those data packets, to deliver your resources, okay? It searches for the fastest route, like what route should I take to deliver this resource to the IP address that has sent the query, okay? So it's also the same thing here in the internet layer. It routes data packets across networks, handles logical addressing and routing, and then it corresponds to network layer. Example is the IP, which is the internet protocol. We talked about it last week, IP address. Next. Next, please. Now, then the last is the network access layer. The network access layer defines the physical transmission of data and provide access to network medium. All right. Combines the function of OSI data link and physical layers. Examples, Ethernet and Wi-Fi. It means when your Wi-Fi is not connected to your physical device, right, you won't be able to get any transmission of data. If your Ethernet is not on, you won't be able to get any physical transmission of data. Okay, so what the network access layer does is it actually combines the function of the data link and the physical layer. Remember, the physical layer sets the ground rolling, like gets everything set. There must be a connection, right, between the devices before anything can happen. All right. For instance, if you're using, okay, let's come to our projector. If you're supposed to use a HDMI cable, right, and you're not using that for that projector, you can't, there'll be no transmission anywhere. You just need to go, if you're using a VDI, right, you can't get transmission if it's supposed to be a HDMI cable you're supposed to use. So that is just what, there must be a connection. There must be a connection. So remember, we're talking about the internet here. If you're talking about the TCP, you're talking about the internet. So if there is no connection between your Wi-Fi and your device, it means you can't get anything from the network. If you don't have access to the Wi-Fi, probably you don't have access to the password, right, or the passcode, it means you can't gain access, right? Same thing if you're in your meetings, your Google meetings, and you send an invite, you don't have access to the passcode, it means you can't join the meeting, right? So these are what happens during all of this transmission of data and gaining access to network mediums, right? Next slide, please. Now here we have a simple table here, okay, of our OSI model and the TCPI. We are going to the TCP and the IP model. This is just a table that differentiates what they actually do and represent, right? So one, the layers here for the OSI, there are 7 layers. Then for the TCP, we have 4 layers, okay? The layer names, we have their layer names, then developed by International Organization for Standardization. Then while the TCP IP model is developed by the US Department of Defense, right? Then the purpose is conceptual framework for network communication. Conceptual framework for network communication. While for the other one, practical protocols used in the internet. You can't gain anything, you can't gain any access to the internet if your TCP and your IP are not practically connected to your device, right? Then complexity, more complex. For the TCP, it is simpler. Then flexibility, more flexible. The other is less flexible. Adoption, theoretical model, not as widely implemented in its entirety, while widely implemented in the internet and most modern networks. Okay, I think that is all for today. Any question? My device just went off. Any question? Let's hold on for my other device to come up. Hold on, please. Give me a load. Okay, yes, okay. Any question? All right, someone asked the meaning of PPP. Hello, can you hear me? Okay, PPP stands for Points to Points Protocol. Yeah, stands Points to Points Protocol. PPP stands for Point to Point Protocol. Yes, your quiz will be coming up at the end of this week. All right. Okay, I'll talk to them. Yeah, point to point protocol. That's PP. All right. It is Martins FTP. It's a network access tool. I gave it as an example when I was talking. File transfer protocol. Yeah, it is. Mm. All right. I think we don't have much questions. I'm so glad we participated in class today. I hope to see you in our next class. Get ready for your hands-on and then have a lovely night's rest.